Hi everyone, welcome back. How are you doing?
Oh, everything is good.
Okay, that's good. So, last lesson we have learned about classic probability, about how to calculate the probability of independence event. So
Yeah.
today we move to another type of probability, which is really interesting: conditional probability. So, what makes conditional probability different from classic probability, and how can we calculate this? Follow this lesson, I will show you. So now let's take a look at a daily life example.
Okay.
Okay, can you see the example?
Yeah.
Yes,
Yes.
Okay,
clearly.
okay. So for example, a girl goes to a fashion shop to buy a skirt. Some skirts are cheap, some are beautiful, and some are both cheap and beautiful. Let's consider these two questions. The first one, what is the probability that a randomly selected skirt is beautiful? And the second one, what is the probability that a randomly selected skirt is beautiful, given that it is cheap? It is obvious that we can figure out that the first question is related to our last lesson about classic probability.
Yes.
Do you understand it? You got it?
Yeah.
Okay,
Yeah.
that's good.
Yes.
And the difference in question two is that it has a condition that the skirt is cheap, and that's why the second question is conditional. In that we already know that the skirt is cheap. Okay, so specifically, suppose that of 18 skirts, 9 are cheap, 11 are beautiful, and 5 are both cheap and beautiful. Now together, I will give you 5 minutes to discuss the solution to the second question by considering the points below. Illustrates the information on the Venn diagram. How many of the scrolls are cheap? That are cheap are beautiful, and which areas in the Venn diagram are to be considered when answering the question, and explain why. And what would be the answer to the question in reverse? Which means what is the probability that a skirt is cheap given that it is beautiful? Okay, that's 5 minutes. I will give you 5 minutes so you can draw the Venn diagram on the whiteboard. I will invite a student to draw the Venn diagram. But can you please?
Yes. Okay.
Okay, that's good.
Uh, okay. Okay. So I denoted A is the event of skirts which are beautiful. So we have 11. B is the event of skirts which are cheap. So we have 9. And the intersection of A and B are the skirts which are both cheap and beautiful. So we have 5.
Okay. Do you understand, Vanang?
Yes.
Okay,
Yes.
she's good. Okay, so let's go back to our question. Okay, so now we will together solve the started question. We will use the Venn diagram that Vanang has drawn before, and denoted A as the event that the skirt is beautiful here, and the event B is the event that skirt is cheap, and with the condition that the skirt is cheap. So now the sample space is B. It means that the skirt must be cheap. You understand?
Yes.
Oh, okay, good. And the randomly selected skirt is both cheap and beautiful. So the probability of that event is probability of A and B. And hence, the probability that a randomly selected skirt is beautiful given that it is cheap is P equal the probability of A and B over the probability of B equal the number of elements of A and B over the number of elements in B, which equal 5 over 9. Do you understand?
Yes.
Okay, I think you have a good understanding of this lesson. So after this example, we've moved to a conclusion and we have this remark. The probability of an event A occurring given that event, event B has occurred is denoted by this, and which reads the probability of A given B, and this is known as conditional probability. And here's the formulas. I recommend that you take note this remark on your notebooks, please. And the probability of A given B differs from the probability of A in that the sample space is reduced to the set B. Okay? So here are the theoretical parts, and now we will move to do some exercise to understand more about the conditional probability.
Now we remove more. Now we move on some complicated exercises for you to understand more about conditional probability. So the first one, exercise 1. Consider this Venn diagram displaying the number of elements belonging to the event A and B. Yes, clearly? Can you see?
Yes, I see.
So we have a 4 question. And the question A and question B we have learned on the lesson before. So I will pick somebody to do this exercise. Who can? Leon, please.
Uh, okay. Because uh, there are there are 5 elements in A, and 9 elements in total. So the probability of A is equal 5 over 9.
Yeah, good job. So when I can you give me the result of the question B?
Yeah. The question B, the number of A and B is 2, and the sample space, the number of sample space is 9. So the answer is 2 over 9.
Okay, well done. So let me check. Yes, correct. Hand clap, please. So in the question D, question C, so I will give you the explanation. So you must do the question D yourself. Yes, we apply this structure. The probability of A given B is equal to the probability of the intersection of A and B over the probability of B. So because there are 2 in common and B has 6 elements, so the result is 2 over 6, right?
Yeah, I see.
Yes, I understand.
Yeah, I understand.
Yes, so
Yeah, I
anyone
see.
can give me the result of the question D? Name please.
Okay, so we also apply the formula above to do section D. Because there are two two elements in in both A and B in the intersection of A and B, and there are 5 elements in A. So the probability of B given A is 2 over 5.
Yeah, do you understand?
Yeah.
I think you're good understand.
Yay.
So we move on another easy question. Just applying the structure. Yeah. Exercise 2. You see?
Yes.
Yes. It's quite long.
A jar contains black and white marbles, and you pick 2 marbles without replacement. The probability of selecting a black marble and then a white marble is 0.34, while the probability of selecting a black marble on the first draw is 0.47. So anyone can give me the probability of selecting a white marble on the second draw, given that the first marble drawn was black. I will give you 1 minute to think. So who can answer my question? Who can do it? Who can? Raise a hand, please. So
Can
just
can
Lian,
you
please.
explain it more clearly?
Yeah. Because I'm not sure about the exercise. So can you explain more?
Yeah.
Like about the sample space or maybe the intersection?
Okay. Let let me let me see the structure. So you see the probability. We must find the sample space. Yes, the sample space is the probability of selecting a black marble on the first draw. So the sample space is must be 0.47. Okay.
Yeah, I see.
Yeah. So who can continue doing this? So I will. Yeah, you see that the probability of selecting a black marble and then a white marble is 0.34. Okay.
Yeah.
So applying the structure, we have the result is 0.34 over 0.47. Okay.
Yeah.
So after calculating, we have a result is yes, 72%. So it's just applying this structure only. So we move on more complicated exercise. Yes.
Yeah.
What is the probability that the total of 2 dice will be greater than 9, given that the first die is a 5? Yeah. You understand the hypothesis?
Yeah, I understand.
Yeah.
So it's a more difficult exercise, so I will give you some idea. Yeah, first, let A be the event of the first die is 5, and B be the event the total of 2 dice is greater than 9. So who can give me the sample space? Yeah, Lian?
I think the sample space here is the probability that the first die is of 5. So we can easily calculate that the sample space is 1/6.
Yes,
Mm.
correct. I understand.
Yes.
Yes.
So anyone can list for me all the possible outcomes for A and B? Madam, please.
Okay. I think there are 2 outcomes because the total of 2 dice is greater than 9, and we have the first die is a 5, so the second must be 5 or 6, so that the total will be greater than 9. Therefore, the number of outcomes, possible outcomes, is 2.
Yes, there are two possible outcomes. So because we have 6.6, 6 multiple 6 cases, so the probability of the intersection of A and B equal to 2 over 36. Okay?
Yeah.
It means that the result is 1 over 18.
Oh.
So we have the probability of the intersection of A and B is 1 over 18, and the probability of A is 1 over 6. So the probability of B given A equal to 1 over 18 divides 1 over 6 is equal to 1 over 3. So do you understand?
Yeah, I got it.
Yes, we see the explanation. So anyone else with don't understand can raise your hand and I will explanation again.
No, I understand.
Okay, guys, so you have explored about conditional probability. Now we move to another part. It is the additional activities. Apparently, we already knew that conditional probability gives us more evidence to solve a problem more easily. And now, let me show you how we use conditional probability to solve a problem in our real life. First of all, I want you to repeat for me the formulas of conditional probability. Do you remember it?
Yeah.
Okay. Um, so I have here for you to see. We have the probability of A given by B and the probability of B given by A. It's okay?
Mhm.
And pay attention on these two formulas. From these two formulas, we can infer a really important formula. Is that here we have the probability of A given B times probability of B equal probability of B given by A times probability of A.
Yeah.
Formula is known as a simple case of Bayes' theorem, which has plenty of applications in our life. And if you don't know about that, don't worry. I will show you an example so that you can understand it easily, okay? And from this example, you can see how interesting this formula is. Here, look at that. I have an example for you. Here, suppose the weather of the day is cloudy. Now, we need to know whether it will rain today given the cloudiness of the day. Therefore, we are supposed to calculate the probability of rainfall given the evidence of cloudiness. Okay, for specifically, I will give you some figure. That says the probability of rainy is 50%, and the probability of cloudy is 75%. And the probability of cloud given by rain is 60%. It means if the weather is rain, so that the probability of cloudiness is 60%. Okay, you can understand it. Now we find from the above formula, we can find the probability of rain given by cloud. That means if the weather is cloudy, so we can find the probability of the rain. Okay? Yeah. So just only by applying the above formula, we can get the answer. Let's see. when we apply Bayes' theorem, we will have probability of rain given by cloud time probability of cloud equal probability of cloud given by rain time probability of rain. Yeah, it's the formula we see it before. You can understand, you guys? You understand it?
Yes, we can apply
Okay, let me
directly.
explain it again. Here, we have the probability of cloud given by rain is 60%. And we have the probability of cloud or as well as probability of rain. Then applying Bayes' theorem, we have this formula. Now we can calculate it clearly. And we got probability of rain given by cloud equal 40%. That means it is really have many applications in real life. This example gives us an idea to predict the weather. And in fact, Bayes' theorem is not only used to predict and give us the weather forecast, but also many other fields like medicine, marketing, and research. However, because of the limitation of time, you should explore it by yourself at home to find more and more amazing applications of conditional probability through the Bayes theorem. And here, I have a list of reference for you so that you can explore it by yourself at home. And don't forget your homework. You have to complete all exercises of section 8D in your textbook and prepare for the next lessons. If you guys have any question, you can give a list of question for me to my email. You've got it. And do you have any question about this lesson today? Okay, if you don't have any question, then we can call it a day now. And you can click the leave meeting below. Okay?
Yes.
Goodbye.
Bye-bye, teacher.
Goodbye.